Today we are going to perform the experiment on energy meter. Objective for today's experiment is to measure the electrical energy consumed by the load. This is our circuit diagram. Here in between phase and neutral we have to give 230 volts 50 Hz AC supply, and this is the phase terminal is connected to the ammeter one terminal, ammeter second terminal is connected to the one wire is connected to the voltmeter, and another one is connected to the wattmeter M terminal, and here voltmeter second terminal is connected to the neutral, and MC are shorted in the wattmeter, and V terminal is connected to the neutral, and this L terminal from the wattmeter is connected to the L terminal in the energy meter. And in energy meter there are four terminals: L, L2 neutral terminal and L1 terminal. In between L and L2 there is a current coil, and in between this NE neutral terminal and L2 terminal there is a voltage coil. Here NE terminal and L1 are shorted. This L2 terminal and L1 terminal are connected across the load, and here meter constant is given as K is equal to 750 revolutions per kilowatt hour. This is our actual circuit setup. We have made these connections as per the given circuit diagram, and only wattmeter connection are unknown to you. If you observe this L terminal, wattmeter L terminal is connected to the L terminal in the energy meter, and this neutral terminal and L1 terminal are shorted here, and this neutral terminal is connected to the supply neutral terminal, and this L2 and L1 are connected across the load. And these are the lamp load. For each lamp having one switch, we can switch on like this. And here now I am going to switch on the supply, and I am going to switch on the MCB, and now we are going to vary the lamp load. When all the switches are in off position, current is 0 amps, voltage is 240 volts, wattmeter reading is 0 watts, and here we have connected the 5 amps coil and 300 volts coil. Multiplication factor is for 5 amps and 300 volts is multiplication factor is 4, so we have to multiply with the 4 for the reading of wattmeter. Now for all these lamps are in off, number of revolutions per 120 seconds is a constant because it is 0 only. It is not this disc in the energy meter is not rotating, so for 120 seconds also it will be 0 revolutions. We have noted down voltage, current, power, and number of revolutions for 120 seconds. We have noted down 0. Now I am going to switch on the 5 lamps. 5 lamps I have switched on, and then I have to note down here current is 2.4 amperes, and voltage is 239 volts, and power reading is 144 into multiplication factor is 4, it is 576 watts. Now I am going to measure the number of revolutions. For that I am using this stopwatch, and now I am going to start the stopwatch. Twelve revolutions given for 120 seconds, that I have noted down here. Now I am going to switch on next 2 lamps. Total 7 lamps I have switched on here. Now I have to measure the current reading is 3.3 amperes, and voltage reading is constant 239 volt, and wattmeter reading is 197 into multiplication factor 4, 197 into 4, it is 788 watts. And now I have to measure the number of revolutions over 2 minutes. 17 revolutions it has given. Now I am going to switch on 10 lamps. I have switched on 10 lamps. Now ammeter reading is 4.7 amperes and voltmeter reading is 236 volts and wattmeter reading is 280 watts into multiplication factor 4, it will be 1120 watts. Now we have to measure the number of revolutions per 120 seconds. I started stopwatch. 20 revolutions it has energy meter has given, and now we have to fill this tabular form by substituting these values. We have to measure the recorded energy, actual energy, and percentage error. Okay. Now I am going to switch off all the lamps and then I am going to switch off the MCB.